In the vast ocean of programming where data flows like rivers of thought, sometimes we need a different lens to see the hidden patterns. Strings, though made of characters, carry meanings far beyond their letters. And what better way to explore their secret essence than to unwrap them in the language of hex, a bridge between human readable symbols and the digital heartbeat of machines. Welcome to our journey on converting a string to hexadecimal in C. We often deal with strings in programming, but what if we need to see what lies underneath those characters? Each character has a numerical ASCII value, and that can be represented in hexadecimal form. For example, the word hello is not just letters, it transforms into 48, 65, 6C, 6C, 6F in hexadecimal. This is particularly useful in data encoding, debugging, and network communication, where data is not stored as plain text but in its raw numerical representation. How do we actually make this transformation happen in C? The process is simple and logical. First, we read the input string. Then we loop through each character one by one. For every character, we determine its ASCII value. Finally, we format that ASCII value in hexadecimal notation. This way, the string is no longer a series of letters, but a sequence of hexadecimal codes that machines easily recognize. In this first part of the C code, we include the required libraries stdio.h for input and output, and strings.h for string functions. We then declare an array to store our string input. Using fgets, we safely read the string from the user. However, fgets also captures the new line character when you press enter, so we use strcspn to remove that. This prepares our input properly for conversion. Here is where the actual conversion happens. We print a label that says hexadecimal representation. Then using a for loop, we iterate over each character of the string. Inside the loop, we use printf with the format specifier %02x. This ensures every output is shown as a 2-digit hexadecimal value in uppercase. Finally, after printing all the characters, we add a new line and return from the program. Let's see this program in action with the word hello. When we input hello, the output is 48, 65, 6C, 6C, and 6F. Breaking it down, the letter H has an ASCII value of 72, which is 48 in hexadecimal. The letter E corresponds to 101 in ASCII, which becomes 65 in hex. Similarly, L is 108 in ASCII, which is 6C in hex, and O is 111, which translates to 6F in hex. This clear mapping shows how characters are encoded under the hood. Why is this conversion so important? In debugging, hexadecimal representation allows developers to inspect how strings are stored in memory. In network communication, data packets often use hex encoding because it is compact and efficient. And in cryptography or encoding techniques, strings are frequently transformed into hexadecimal for security and consistency. Thus, what makes seems like a simple transformation has wide-ranging real-world applications. Let's summarize what we have learned. We can read an input string using fgets. By iterating through each character, we can convert them into hexadecimal using the %02x format specifier. This gives us a consistent and precise representation of the string. Hexadecimal encoding is a universal tool, bridging the gap between human readable text and machine level data. So the next time you see a string, remember it has a hidden hex identity, quietly waiting to be revealed. Thank you for your attention.